Hello students, welcome to my YouTube channel.
Next measure of central tendency is median. Median can be defined as middle value in a set or distribution. The values that divides the distribution in half when observations are ordered. As we have seen in the introductory part of the median, so in order to determine the median, first we have to order the values. Either it may be ascending or descending order. When the series of values are arranged in ascending or descending order of magnitude, the values of the middle item in the series is known as the median here. So in this way that we can find out the median here. So this is the formal definition of the median that we can say. So here in this example you can see, so the values that are given here are 5, 8, 9, 10 and 28. So what is the median of this? So first we have to arrange these values in the order. So these values are already arranged in the ascending order. So what is the middle value here? Okay. So when n is the odd, the number of data points or the values are odd, we can easily find out the median here, or the we can easily locate the middle value here. So that is nothing but the median. But if the n values are even here, or the n numbers are the evens here, so in that case here we have to take the average of two middle values here. Here the average of 19 and 20 is taken, so that is the 19.5. So this is the median of the value here. So let's we see this with example. First the median for the ungrouped data. So how to find out the median in a group of numbers here, so that we will see. So first step here, arrange the number in order from least to greatest. So remember one thing here, first you have to arrange the values in a order. If you don't arrange these values in order, you will not get the median. First arrange the values in order, so then find the middle number. So once you locate the middle number, so if there are two middle numbers, find the mean of these two numbers. When there will be the two middle numbers, when n is equals to even. When n is equals to odd, you can easily locate a single middle number. In case of n is even, you have to take the average of two middle values. As in this example, here you can see. So how we are locating this? So in this example, the median is the 7 here. Okay, so by mistake it is given as the 10 here. So but here the median is the 7. When you order these values in a ascending order, so the median is the 7 in this. So in if the n is the even, so then you have to locate the two middle values as we have seen here. You have to find out the average of these two values, so that will gives you the median of this data set. It is very easy to find out the median for the ungrouped data. Let's we see how to find out the median for the grouped data. So this formula is very helpful for calculating the median of the grouped data. First, we see the what is the meaning of the all these symbols that are used in this formula. So L1 here. So L1, the formula that is used is the M is equals to M indicate the median of the that given data. So M is equals to L1 plus N by 2 minus CF divided by F1 into H. So in this, L1 is nothing but the lower limit of the class in which median lies. So L2 is nothing but the upper limit of the class in which median lies. So we need to know the L2 for finding the value of the H. So H can be determined from the lower limit of the median class and the upper limit of the median class. F1 is the frequency of the class in which median lies. So n by 2 is nothing but the position of the median. So you might have observed that the first we have to locate the median class, then only we can find out the lower limit, upper limit, and frequency of the median class. The median class is located or determined by using this formula, that is the n by 2 here, the position of the median here. Okay, so in this class the median will lies. So cumulative CF is nothing but the cumulative frequency of the group preceding to the median group, just one group before the median group here. So let's we see this with some steps here. So what are the steps that are included in finding the median of the grouped data? So first step, arrange the class interval in order. Like the grouped data, you have to order the all the given data points, then only you can proceed for determination of the median. So here whatever the class intervals are given, first you have to order this class intervals, then calculate the cumulative frequency here. As we know that whenever the class intervals are there, the frequency is there. So you have to find out the cumulative frequency, then identify the class in which the median lies. As I told you, so this formula is very important for locating the class in which the median lies. So that can be located by using this total frequency. How we are determining the total frequency? Total frequency is given by this n. So this n is nothing but again the summation of the all the frequencies here. So f I. So that we have seen already. I is equals to 1 to n. So by using this formula, we can find out the total frequency. So total frequency divided by 2. So this will locate the median here, in which class the median lies. So then after calculate the median value from the formula here. So use this formula and find out the median value. So these are the some steps involved in calculation of the median of the grouped data. So let's we see the one example of the median of the grouped data. Here you can see the class intervals. So 40, 50, 50, 60, 60, 70 and the frequencies are given here. So you have to find out the median of the grouped data. The very first step in determination of the median of the grouped data is first you have to order the class interval. Let's we check so whether the class intervals are ordered or not. So when you observe this 50, 60, 70, 80, 90, 100, 40, 50, 60, 70, 80, 90 means the class intervals are ordered. So then next find out that locate the class in which median lies. So how we are locating the class in which median lies? So by taking the summation of the all these frequencies, that is the total frequency of the all the classes here. So before that here, so okay, before moving to this cumulative frequency, let's we do the addition of the all these frequencies and we can find out here. Again one more column that you have to make there. So you have to make there. So that is a for the cumulative frequency. The cumulative frequencies are given in this column here. So total summation of these frequencies is 55. So that we got from the cumulative frequency also. So the next one here, so once we find out this frequency, so then divide it by the 2 here. So then we use this formula. So 55. So we have to find out this value now. Remember this n by 2. So this n is nothing but the summation of the all frequencies here, or the total frequency that we can say n is equals to. So then n divided by 2, that value we have to calculate. So find the median class by using this formula here as I told you. So n divided by 2 is equals to here 55 divided by 2, then we get 27.5. Once we locate the median class, so what is the meaning of this 27.5 is the in the from the frequency that we have located the median class. So you have to go through this cumulative frequency here 5, 13, 25, 45. So 27.5 is more than this 25 but less than 45. So where it will come here? So this will come into this class here. Okay. So frequency class. So after this 25, the 27 will come when you talk about the cumulative frequency here. When the cumulative frequency 27.5, where it will come? So it will come in this class 70 to 80. So that's why this is known as the median class. Your median is in this class. Now we have to locate which one is the median here. Okay, so just we have located the class in which median lies. So next here, so we use this formula for locating the for finding the median here. Okay, so here you can see that is the L1 plus n by 2 minus cumulative frequency divided by frequency of the median class here. What is the frequency of the median class? The frequency of the median class is 20. So H here we have seen that is the L2 minus L1, that we find out the value of the H. So the explanation of the all these steps is given here. Okay, so the median is equals to the frequency of the lower frequency of the median class. So this is the 70 is the lower frequency of the median class, and this is the upper frequency of the median class. This is lower and upper frequencies. Remember, the lower frequency of the median class is 70 plus n by 2. Here we have calculated the value of the n by 2 minus cumulative frequency of the preceding class. So this is the preceding class. So this is the median class. So the preceding class of this median class is the 60 to 70, and the cumulative frequency of the preceding class is 25 divided by frequency of the median class. So here we have located the median class. So this is the frequency of the median class into L2 minus L1. Remember, L2 minus L1. So this is nothing but the H here. Okay. So L2 is, this is the limit, this is the limit of upper limit of the median class, and this is lower limit of the median class. Take the difference of this upper minus lower. So you will get 10 value. Hope everybody getting this. How we are getting the all these values. Again, I'm repeating here. So L1 is nothing but the, here you can see L1, this is the lower value of the median class, and this is the lower limit that we can say of the median class. L1 plus n by 2 total frequency divided by 2, n is nothing but the total frequency, minus cumulative frequency of the preceding class, means the preceding class of the median class. So this is the 25 divided by frequency of the median class, this is divided by 20. Here we have taken, this is the 20 into upper limit of the median class minus lower limit of the median class. So that is a 10. So put all these values, you will get the median equal to 71.25. So this is overall about the calculation of the median of the grouped data. Let's see the next point, mode. So mode is the value that most frequently occur in the given data. The number whose frequency is more than the other is called the mode. It's very simple. You have to just locate based on the frequency here. Data set with only one value occurring highest frequency is called the unimodal. Two values that occur same highest frequency is called bimodal, and the more than 2 is called multimodal. There may be more than one highest value in the data set here. If there is the only one, there is a number of times that value is repeated there. Okay, so when the frequency data is given, so we can easily locate for the interval data whose frequency is more. So that is known as the, that class particularly, so that we consider as the mode. So there is a, for that unimodal, we can say if there are more than one highest frequencies, then that is known as the bimodal. So mode of the ungrouped data. So this is the example of calculation of the mode of the ungrouped data here. Okay, so number of times that value occurs in the data set. If that the number of times that value occurs in the data set, that we have to first find out here. The 8 value we consider, the 8 is occurring 4 times here. So 29 is only 2 times here. Here I write 29, frequency of the 29 is 2, the frequency of the 8 is 4. Frequency of the 4 is 2. Frequency of the 19 is 2 here. So among all these, the 8 is having the more frequency here. So that's why the mode is 8. It is very simple for the ungrouped data. Let's we see this for the grouped data. So calculation of the mode of the grouped data requires the some mathematical calculation or the formulas here. As you can see here, the mode is calculated, that is a L1 is the lower bound of the model class. As in a median, we have first located the median class. In the same way, first you have to locate the mode class. So this is the lower, L1 is the lower bound of the model class. So then FM is nothing but the frequency of the model class. F1 is the frequency of the class preceding the model class, just before the model class. So this is again the F2 is the frequency of the class following the model class here to the next to the model class, and H is the width of the class interval here. Width of the class interval same we can find out from the L2 minus L1 also. So what are the steps that are involved in the calculation of the mode of the grouped data? The first step is identify the model class, the class whose frequency is highest. So that class you have to identify. Once you identify a class whose frequency is highest, so then determine the values of the lower bound of the model class, frequency of the model class here. So then frequency of the class preceding to the model class, frequency of the class following to the or the next to the model class, and width of the class here. So then put all these values in this formula, so you can find out the mode of the grouped data. Let's we see the one example of calculation of mode of the grouped data. So in this, first we have to locate the mode class here. So this is a grouped data. So which class has the highest frequency? The class 70 to 80 has the highest frequency, that is a 25. So this is known as the model class here. So what is the lower limit of the model class? So that we have to find out here. The lower limit of the model class is 70. So that's why I put this value here. The next one here, frequency of the model class. The frequency of the model class is 25. So frequency of the model class 25 minus frequency of the class, just that is a preceding to the model class here. So that is a just before one class of this model class. So this is the class 60 to 70 class. So frequency is 20, which is just before the model class. So this is the 20. So then divide by frequency of the model class minus frequency of the class, frequency of a class just before the model class here, plus the frequency of the model class minus frequency of a class that is the succeeding to the model class. So just after this model class, which class is there, so and take its frequency here. So that is a 10 that we got. So into the, this is the H. So H is nothing but the L2 minus L1, upper limit minus lower limit of the class, so that you have to take. So 80 minus 70, we get 10. So H is equals to 10. Put all these values in this formula and you will get the mode of the this